Hi students, welcome back to mathematical physics course. I came back after a long period of time and the reason is I was busy in some my personal PhD work. Now I will try to upload video regular basis. So in this video we will discuss the chapter number 3, integral representation of the function, and in which a specific case we will look for, and it is error function. Okay, so this is the section number 3.1, the error function, and next section will be 3.2, Fresnel integral, and then gamma function I will be discussing in the next videos. Okay, so let us proceed and look how to visualize this function. Here we are going to discuss the chapter number 3, integral representation of function, and the section is 3.1, error function. So let us first look at what is the definition of integral representation of a function. Sometimes what happens is that you are not able to integrate a function in closed form, and it is not possible to fully integrate a definite integral. So we write some function in integral representation. So you see here f of x, here I am writing like this, from limit a to b, some given function f of x comma y dy. So here this, where a comma b and phi are given. So if these three things are given, then the function f of x will be called a function of x in the integral representation. So here if sometimes it is not possible to solve, completely integrate this integral. Okay, so here we see that these two limits are constant, but a more general case can also be defined for this integral representation of a function, and it can be written like this: f of x, some limit from a of x to b of x, phi of x comma y dy. So this is more general one. Okay, so now we will look for the Gaussian integral, incomplete Gaussian integral. So in chapter 2 you saw that in chapter 2 the integration from 0 to infinity e to the power minus t square dt, it is root pi by 2. So this is Gaussian integral, the famous Gaussian integral you saw in the previous chapter, chapter number 2. Okay, now since here the limits are constant, now we are going to define a function, and this function we define like this, error function, which is I am giving the definition d of, we are defining the error function like this: 0 to x e to the power minus t square dt. So we are defining a function, error function, like this. So here the limit is not a constant limit, it is a something variable, which is x here. So this is an incomplete integral, or you can say incomplete Gaussian integral. Okay, so you can't solve it on the closed form. Now let me tell you one more thing before going into the properties of this error function. We will look for how to derivate a function which is written in terms of integral representation. So suppose a function f of x is written like a of x, b of x, phi of x comma y dy, then you are asked to calculate this. How will you write this? So to write this, I am telling you a formula. So to write this, you will do like this. So this is the formula when you are asked to calculate the derivative of a function which is written in terms of integral representation. So using this formula we will calculate the differentiation of error function. Okay. So let me tell you one more thing is that error function, some properties of error function. So error function looks like 0 to infinity, sorry, x. So this is defined in this way. One more thing I want to tell, that here you have to write this. So this is the definition of error function. Okay, so this is not derived from somewhere. This is the definition of error function, and here this constant factor which is in front of this integration is put in such a way that I must tell you that let me tell you that if you put a limit x tends to infinity, in that case what will happen? This error function will convert into the Gaussian integral, correct? So the integral will give you pi by root pi by 2, so that it becomes 1, correct? So that's why the factor of root pi by 2 by root pi is put there. Now we know the limit. So if you want to check, you may check, it is this error function of 0 at x equals to 0, error function of minus infinity is minus 1. So if I ask to calculate this, how will you do this? So simply what you can do is that error function of x is written like this, 0 to x e to the power minus t square dt. So you can write like this also. Just what I did here, I flipped the limit. Now this can be written like this, and you can put here the limit x tends to minus infinity. So error f minus infinity minus 2 pi by root pi minus infinity to 0 e to the power minus t square dt. So this is the integration in the second half x axis. So you already know the value of 0 to infinity e to the power minus t square dt, and which is nothing but root pi by 2, correct? And here the integrand is even function. So if the integrand is even function, then the integration from minus infinity to 0 will equal to this integration. So this is nothing but equal to minus infinity to 0 e to the power minus t square dt is equals to root pi by 2. Why it is the case? Because the integrand is even function. Even function means it is symmetric about the origin. So here you will write minus 2 by root pi, and this will give you again root pi by 2, which is minus 1 here. So error function of at minus infinity is minus 1. So now we know how many properties? We know the properties: error function at infinity is plus 1, error function at 0 is 0, error function at minus infinity is minus 1, correct? We know these three properties and we name it some equation. So let us call it equation A, correct? Now, so we can look now for the one more property which is called even odd property of the function. So exact explicit form of the error function is here, 0 to x 2 by root pi in front of the integration e to the power minus t square dt. So here you can see that error function of x, sorry, minus x is equal to error function of x. So you can look it from here. This means it is odd function. So error function is a odd function. This is we call it the property number p. Okay. So you can verify this at x equals to plus infinity and x equals to minus infinity. Plus infinity plus 1, minus infinity minus 1, correct? Now let us look at the derivative of the error function. So to look at the derivative of the error function, use the formula which I earlier told you to derivate error function, and it will give us 2 by root pi e to the power minus x square. Use the same formula which I already told you earlier, this formula. Use this formula to get the derivative of the error function. So the third term will vanish because the lower limit is 0, upper limit is x in case of error function, so this derivative will become 1, and here you will get the integrand. This will also become 0 because here you are derivating with respect to x, but the integrand is in the function of e to the power minus t square, and you are derivating with respect to x, so this term will also become 0, this term also become 0, you will have only the middle term, non-zero middle term, when you derivate the error function, correct? So here we go, and you get this, the derivative of the error function. So now we see here, this is always positive, so derivative is even function, and we see it that it is always positive because e to the power minus x square is always positive, and it is also positive factor in front of them. So it is always positive, and even derivative is even function. So if I say you to draw the error function, what will you do? Just make the axis. So these are the, this is x axis, this is the minus infinity side, this is plus infinity side, and this is error function axis. So we know the from the property, so let us call it the property number C. So from property A we see that error function at infinity is 1, error function at minus infinity is minus 1, error function at 0 is 0. Okay, and it is also a odd function. Error function is also an odd function. That means if on the positive half x axis, if it is positive, then it will be just the same graph in the negative side, but a negative value. So let me tell you one thing. So suppose, let me make some constant line. So these are constant line where it is plus 1 line, and this is minus 1 line. So error function is 0 at x equals to 0, this is 0, comma 0. Okay, this is minus 1 comma 0, sorry 0 comma minus 1, and this is 0 comma plus 1. So error function at infinity becomes positive and 1. So it start from here, it becomes 0 at here, so it go like this and come like this. So if you want to verify that I have made the figure correct or not, you can look at the slope also. It says slope is always positive, so you draw the tangent on this error function anywhere, you will find that the tangent will make the angle less than 90 degree from the positive x axis, correct? So if you want to draw a tangent at this point, you will draw like this something, axis tangent passing through this point. So this will make angle less than 90, acute angle from the positive x-axis. So slope is always positive. And you can look for the slope at x equals to 0. So slope at x equals to 0 is 2 by root pi, which is not equal to 1. So slope at x equals to 0 is 2 by root pi, which is not equal to 1. This means this, if you draw a tangent at here 0 comma 0, this is not equal to 45 degree. Okay. Yeah. So this is a rough plot of a error function. So what is the application of this error function? So you see this application of error function in cumulative probability density function, which you will see in the probability theories, where you see the standard normal distribution, Gaussian distribution. So in probability theory you face this error function many times, so that's why I told you here. In next video you will look for the Fresnel integration and the gamma function. At last I want to give you an exercise. Before you come to the next video, I hope you will solve it. I will discuss this solution in the next video. So exercise is that complementary error function. So the definition is this: complementary error function is written like this. The definition from 2 by root pi x infinity dt e to the power minus t square. So if you get the relation between complementary error function and error function, will be good for you. Solve this exercise and find the relation between complementary error function and error function.